Hello. If you watched the first video, I put in the lesson plan the video from Pearson. On my MATLAB, you saw examples of how to solve a conditional equation. So those are examples of equation. I mean, those the examples that you saw there, where there's only one solution, are conditional equations. But you can have two other cases. You can have an identity, which is an equation in which every real number is a solution, and a contradiction, which is an equation that has no solution. So let's do an example of an identity. Let's suppose we want to solve -3 times x plus 3 plus 5x equals 2 times x plus 1 minus 11. Okay, we're going to start by distributing the x's or distributing the -3 and the 2. So -3 times 3 is -9. And then we have 2x and 2 times 1. Next, we're going to combine like terms. At the end, the purpose is to isolate x on one side and the constant on the other side. Yeah, so combine common like terms. -3x plus 5x is 2x. And then 2 minus 11 is -9. So we have the same expression. If we wanted to go a little bit farther, let's say subtracting, I mean, we don't need to go farther than that, but if you were trying to do that, for example, passing the 2x on the other side, you would have that -9 equals 2x minus 9 minus 2x. So what I'm doing is passing the 2x to the other side, and at the end, the 2x's cancel out. So I ended up with -9 equals -9. Would you know that this is always true? And this equation is an identity. And the solution set is all real numbers. So the equation is an identity. And the solution set is all real numbers. Now that's what the book has for the set of real numbers, just written within braces, but there are other ways to write it. It can also be expressed with this R. So that indicates the set of all real numbers. Or we're going to learn interval notation in the next section where we cover inequalities. So another way to say it is -infinity to infinity. But for now, this notation is okay, all real numbers. So you can plug in any real number. For example, you plug in x equals 0. The equation is going to be a true statement. Or you plug in 1, or you plug in 10, or you plug in -100. This equation is always going to be true no matter what real number you enter. And the other situation is a contradiction. For example, let's solve. The equation 4 times x minus 2 plus 7 equals 2 times x minus 3 plus 2x minus 4, or plus 2x plus 4. Okay, we need to simplify. Some things first. Distribute the 4 and distribute the 2. Next, combine like terms. -8 plus 7 is -1. 2x plus 2x is 4x. And -6 plus 4 is -2. And then if you take the 4x, you pass it to the other side, you get that -1 is 4x, -2 minus 4x. So 4x minus 4x cancel out, and -2, or -1 is -2. Would you know this is a false statement? So the equation is a contradiction and has no solution. Okay, so these are the exact, well, there's something else. One way to say it is that the solution set is the empty set. Denoted with the symbol, or denoted by the symbol, this circle, also this circle or this symbol is the symbol for the empty set, the set that has no elements. So these are the two situations that I wanted to illustrate. An identity where every solution or where every number is a solution, and a contradiction where there's no solution. Thank you for listening.